You once again. Today we are going to be looking at the general slope analysis. When we talk about the slope general analysis, we are going to be seeing how people how people came to observe the slope and what did they find out in terms of the relief from the hilltop down the slope, or what you can refer to the upper convex sediment. And then when we reach down, in other words, we are going to be looking at the slope occurrence may result into what we call the geological structure. We look at the climate, even sometimes look at the vegetation, we look at the drainage network, also look at the drainage texture, then also we look at the frequency, uh, where we shall talk about the absolute relief, relative relief, and erosion. Then we look at what is the relief endowed with in terms of radiographic attributes in the study of landforms or drainage basins. That is what we call the slope or the general slope analysis. When you look at the diagram below up there, we have what you call the upper convex segment. When you try to ascend down, then you have what you call the slip off face, or what you can call the cliff face. From there, we go and look at what we call the straight sediment, in other words, the gently sloping landscape, and also we look at what we call the lower concave sediments in there. So that's clear. Shows how the general slope looks like. However, we are seeing that the upper convex segment, for it is associated with in terms of vegetation, it tends to be having limited vegetation, and also it is also characterized with what we call bare rocks or hard rocks. Then when we move on, we also see what we call the cliff face. When you talk about the cliff face, it is also associated with what we call weathering, erosion, then transportation, but most dominant activity or denudation activity that may be taking place in areas that are associated with the cliff face. It is the first runoff of material or weathering and erosion, plus what we call transportation. When we move on to what we call the straight segments or segment, that part for it entails or it has got what we call a deposition. Minimum deposition starts from that side. So in other words, when the material tries to move from the upper convex segment, it will finally go through what we call the cliff face, and it will always settle or concentrate in areas with a straight segments. That's what we call the segment, which or it is associated with what we call deposition. From there, we pick up and we look at what we call the lower concave sediment. When you talk about the concave segment, for it has got what we call deposition mainly. It is associated with the deposited material, and also it is associated with sand, stone, and all other weathered material. That is what we call the concave segment. When you try to move on in terms of the concave segments, there are different features that may be formed. What I did not talk about, it is the vegetation type. So areas associated with lowlands, sometimes they have what we call the swampy mangrove vegetation, and when you move to the gentle slopes or what we call the straight segments, for them they are associated with what we call tropical rainforests or equatorial rainforests. When you move up to the concave convex and the cliff face. For it, you are associated with what we call bamboo, temperate, and also talk about heath and moorland in terms of the location. Those areas, they are associated with those different vegetation types, and most importantly, they have got what we call the bare rocks. Those are what we call the description according to different vegetation as they are spread there. And now when we move on, we are going to be looking at which landforms may be formed in different areas. They're saying that a slope is a key factor for the in describing and analyzing landforms and the development of formations of different landforms as a dependent on the slope and the processes of slope development. So the analysis of the slope is very important in metallic analysis, as we are going to be seeing. When you look at what we call the upper convex sediment or segment, for it is associated with the main uplands. When you move up to the cliff, I shall be seeing what we call the spurs, the interlocking spurs. Then talk about also a waterfall on the side of the cliff face. Then when you move on up to down on the sediments, we shall be seeing now depressions being created. Then when you move down, we are going to be seeing deposited material, or what you can term as moraine being deposited there. It may be deposited by rivers or by the running material along the slope. That is how the slope is displayed. When we move on, we are saying that they are talking about how we can calculate the average slope. For it looks at what we call the total length of the contour times the contour interval or the contours interval, then you divide them by the total area. That's how we establish the average slope. When you continue below, they are showing how they get for us these units there. They are saying that the analysis of the area can be divided into what we call 4 major slopes or groups via the gentle slopes, moderate slope, steep slope, and very steep slope. So they measure them in degrees. Then after they convert them here in the above formula. When you continue, they are talking about in terms of location, depending to the degrees that they might have obtained there. Then below we have a formula for finding the gradient, that is the vertical interval over the horizontal equivalent. When we talk about the horizontal equivalent, that is the straight distance times what we call the horizontal distance. Straight distance times the horizontal distance, that's what we call the horizontal equivalent. The straight distance is the straight distance that you measure straight away. Then the horizontal distance, for it you look at the map, then you obtain those units in there. So that is the map trying to show you what we call the straight distance. When you look at point A and point B, that's what we call the horizontal distance. And when you look at points that blue color, it clearly shows to you how the spread of that river may be appearing. But there are those dots that are being tried to display there. That's what we call the horizontal distance. The other one is the straight. This one with the dotted in red is what we call the horizontal distance. The other one is called the horizontal, the straight distance. So that's how we can calculate that. Now when you look at the other diagram, they're trying to show the contours, how they are spread. We are seeing the two much compacted contours in there. So this one, there are also some of the calculations that you maybe use. You're saying that knowing the contour lines and the lines joining places of equal heights on a map, they are saying that subtract the highest value from B that of A. In other words, they are looking for what we call contour interval. As I told you last time that when you look at the contour or what you call the vertical interval, for it is the distance between the two successive contours or two neighboring contours. In other words, you get the highest contour minus the lowest.